Welcome to Cute Widgets and More. In this second episode of the mini-series of 4 on templates, we'll turn our attention to template specialization. So in today's episode, we'll go from simple to understand to somewhat more abstract and complex, but at the same time, something that is somewhat difficult to find a good example for, to something that is very applicable when you're doing template metaprogramming. We'll start out looking at sort, and the sort will actually have 2 different versions of sort, depending on the input type of what we want to sort. If we sort regular stuff, then we'll do one thing. But if we sort characters, then we'll use a completely different algorithms. We could, of course, have solved this problem by just calling the method different names, but we can have the same name for different types. So the way we do it is by making mySort a templarized method. So template, type name t, mySort. It takes a vector of t's here, and well, it does something. That's not the important part. Down here, we, however, say, okay, we still have mySort, so the name is the same, but this time the parameter list here is empty because we have specified the full list of names here. So template, nothing, but I still need to tell it that it's a template because I don't even know the technical term, overloading this other template over there. But this time with a stud vector of chars. And well, we can look at the implementation if we really want to. The mySort is just calling stud sort with generalized t. The mySort down here with the char, the specialization, it simply creates an array of the 256 possibilities of chars, and then it updates that number every time I see. And when I then print it out, I run through them and print as many of that character. We can run the application if we really want to, and we'll see here that calling the default method, that was the first part here, calling the default method, and then calling a specialized method with the characters, and we can see that becomes a low. So just as it was the case with templates in general, where you could do it for functions and for classes, you can also do the template specialization for classes. And it's not entirely trivial to come up with a simple example for that, but we found one that is okay examples nevertheless. It's so okay that it's actually more or less to be found in C++23. The idea is a return value. Imagine a function that returns a value. That shouldn't be that difficult to imagine. But it could also be that there was an error and then it should return an error code instead. How would you do that? Well, one way that we've done this for ages is that we would take a parameter to the function which was a int or a bool or a string or whatever pointer where the function could put its error value into. And then whenever we got back, we could look at that. But what we also can do is that we can use a template, because we want to generalize this. We could, of course, just return a class with the value or the union with the value or the error code. But if we want to generalize this on the value return type and on the error return type or the error type, then we would use templates. Let me first show you the template for that before we turn our attention to the specialization. So it looks like this: template, type name, value type name, error type. So this is the type that my value has and the type that the error has. And if we just scroll down and see some usage of it here, hResult. hResult is a using. So using hResult, that is a result, the class that we're talking about, of an integer. So what is your age? 22, and potential error string. And we can even see it used in here. So who are we looking for? If we're looking for Jesper, me, that would be 18. Thank you for believing that. If we're looking for Jesper's wife, then the error result should be, you do not ask a woman for her age. And otherwise, the error should be the unknown person. And down in the usage here, we can see that I'm asking for Jesper, and I can return that by the hResult.value. That's a method we'll see in just a minute. We can also ask for Linus Torvalds, and then it will be told that we are we'll be told by hResult.error about the error message, and we can see the hResult has value telling us that no, it doesn't have a value, it actually has an error. Let's go and look at the implementation. It's really not that difficult for this one. Value type, error type, and result here, that's our class, that's specialized. Result with this value type here, I'll just add it in an instance variable. Result with the error type, I'll keep that as an instance variable, and then my result is a variant of the value type and the error type, and well, we are operating this variant up here. So far, so good. There's just one catch, namely my very last sentence. I said the data is stored as a variant of the result type and the error type. But what happens if I have a method that do not return anything, but I still would like to check for the error message in this framework here? Why wouldn't I just return the error message? Well, because maybe this is a more generalized framework that I'm setting up where I can call stuff like this. Then, in that situation, the variant would be a variant of void, comma, the error type, and that is not a valid variant. So there I need to specialize my results template without that void in the variant. So here is the specialization. Class result void. Let's just go up here and collapse this so we can see. Template, type name, value type, error type, result, blah, blah. No specialization in the syntax there. And if you think that, hey, this syntax here is really weird, well, that's just the syntax of template specialization. Cope with it. So up here we say the specialization is now without a value type. So the template is only specialization using the error type, and the result is void, comma, and then the error type. And what I do then is that I simply remember my error. If I had an error here, there's also the default constructor up here, has error, checks for whether my error, and that error type here is an optional. So do my optional have a value? That is the case where I actually assign to it like this. So here we have a specialization now on the value type while still being temporized on the error type. I could have even a specialization where I had void, comma, int if I wanted to treat integer error specifically, and then it would say template less than, greater than, just like we saw in the previous one where we had this template less than, greater than without anything in it, and then void, comma, int. The usage down here, I have an error that is no permission and unknown command, and then my action result is a result, just using the syntax, using action result equal to result of void, comma, this error enum up here, and do action look like this. If it's a reformat text, then that's perfectly okay. If it's format C colon, then there's no permission, otherwise unknown command, and we can use it down here just as we expected. I hope that you agree that this was an understandable example. I'll go pretty meta now and just have something totally random just to show you 3 more examples of what this looked like. And the last one, trust me, is likely the most useful thing that you've seen up until this day in Qt Widgets and more. Whoa, that was quite a bit of a promise, huh? Let's see. We now have a template TNS on our class foo, and foo takes this TNS and print out most generic version. Then we have a template only on T this time, so that's this parameter that still is being temporized, and then an integer for that parameter. I can print out something here, taking a T and an int. Now I am temporizing on the other parameter, so I'm fixing this first parameter, string now, and T, and printing out here. And finally, the most specialized version, both of them being integer. Observe the less than, greater than syntax up there. I don't know why I keep telling you that, but that was a part that really blew my mind for a while. What does that even mean? Well, it's template specialization. So down here, I can now call the foo with char and string, and the compiler will look at it. Int, doesn't work. String T, well, char and string doesn't match. T and int, well, T could match, but int and string is not the same thing. Remember, I'm looking for char and string. And then T and S, okay, that matches, and then it will call that one. Next, char and int. This one matches, it always does, but it's also the most generic. So the rules for how the compiler will choose, I'll not even get into those, but the more generic or the more specialized, the better it is, basically. So we're looking for char int, and we see char int. This one would go, this one wouldn't go, and this one wouldn't go. So we'll be using this one. String. This one wouldn't work. This one would work if T was a string, and this one, of course, always works. And then finally, int, that would hit this one down here, even though this one and this one works too, but this one is more specialized than the others. And we do the same thing again, this time without specifying explicit types, and the compiler will deduce what are the types based on the parameters and then figure out which to call. Bear with me, I know that it's getting somewhat abstract and not applicable right away, but it is the foundation for SFINAE. Substitution failure is not an error technique that we'll be seeing next, and that is very, very important for what we'll be seeing throughout the end of this mini series here. We saw that there was a generalized version, the one that took a T and an S, that would always match, but that is not necessarily the case. It could be that we didn't have the generalized version, and then we get an error if we didn't match any of the others. Let me show you what that looks like. Because contrast to what you might expect, you actually need to specify the generalized one, even if you don't have an implementation for it. And that's what you see here on line 29 and 30. Template type name TNS of foo. So I'm saying that I have this foo class, which is a templarized one. And I need to specify that to be able to implement my specialization. If I didn't have that, and I tried to compile, say, explicit specialization of undeclared template class foo. So that's the first thing to understand here. I need to have it. And second, once I have that, I can now go and make my specialization. Here's my class foo with a T and an int, and my class foo with a string and a T, and so on. And of course, this one here doesn't work anymore. Implicit instantiation of undefined template. And let's just build this because it's going to give us something super interesting to look at. Implicit, I hope that you can see it. If you're on a phone, you better but just listen to what I'm saying here. Error. Implicit instantiation of undefined template. Parenthesis start anonymous namespace. That's because I have this namespace around everything here. Colon foo. That's the foo that we have here. Comma char, comma std, colon basic underscore string, less than char, greater than. So what it told me here was that I tried to instantiate this foo templarized class with a specialized version, or with a version basically with a char and a string. That's what it said here. Yes, Burr, can you get to the point? What's so magic about that? Of course it says so. Well, it told me there was a char and a string. You still don't get it. But it wasn't just that char that read up here and the string that read up here. Actually, it said string. Instead of string, it said this std basic string, which string is really about. What it told me was a data type of these. And that is one of the most important things when you do work with templates. One of the things that are most annoying when you work with templates. Namely, maybe I should go full screen. Namely, that you have a T and an S and a V and a W, or whatever you call your template parameters, and it just doesn't work. And you ask yourself, but what did it deduce, this T, the capital T, or the lowercase t, namely the instantiation of your T? What did it deduce that type to be? And here is the trick for doing that, namely to create a generalized or a template that can be specialized, which you do not specialize at all. And when you try to invoke that, the compiler will say, I didn't find a specialization of this generalized version. By the way, I saw that you gave it a char and a string, and so so you deduced it to be a char. Let me show that to you in the last part. So line 29 and 30, you will find that cluttered out through all of my code. I really just ought to write it once and include some file with those 2 lines in. What does it say? Well, I have a template that is a variadic template on a number of parameters. And it's a struct, so it's a temporized class, temporized struct called PT for print type. And there's no specialization anywhere. So every time I try to instantiate PT, it will say, sorry, I don't know any specialization of that particular thing. And let's just try and go down here and do it. So we have this go, which takes a bar. So go here takes a bar, and it does that with a ampersand x. And I'm going to blow your mind now if you haven't heard of this. This is a forward reference that we have here. This is not a R-value reference, it's a forward reference. If you haven't heard about that, better go and look that up right away. Anyway, what is the type of T? What is the type of X when I go giving it a bar, parenthesis, open, parenthesis, close? Let me see. Bar is a R value, right? So when I go and give it a forward reference to an R value, then X will be an R value reference, and T, X will be an R value reference to a bar, and T is bar. But really, well, let's just go and print it. There we are. Implicit instantiation of undefined template. Yes, I expected that. And it just goes off the screen here. Isn't that beautiful? But we can, well, down there you can't see it. Anyway, I will read it up for you what it says out here. Maybe I can actually, on the compilation output. Oh, I can make that bigger. Of course I can. Over here it says, error, implicit instantiation of undefined template. Anonymous namespace, : PT. That's fine. And then less than, that is now, it's printing us the T here. Anonymous namespace. Yes, we are in an anonymous namespace, : bar. So T here is type bar. But how about X? And for that, we need to have, let's just comment this out again and comment this one in. For X, we need to ask for what is the type. And that is done using this decal type. There I go and say, can you give me the type of X? So decal type X, that is similar to what type X has. And we'll build again. We will look at the output here. And we can see now that it says implicit instantiation, blah, 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 of bar reference. So X is a R value reference to a bar. You might not realize the value of what I just showed you here, namely that you can make your compiler tell you what is the type of any given class. But here's a small test. Let me just write something here on the screen. I have magic fingers. So const in equal to 42. Okay, what's the type of int? Well, of I, well, of course, it's a constant integer. But how about this? Auto j equal to I. What's the type of j? Is that an integer or a constant integer? Oh, you forgot. Well, let's ask our compiler. Let me show you. So const int equal to 42. Auto j equal to I. So is j const or not? How about if I move my I? Will k be a const R value reference, or what will it be? So we can see here, my decal type of j is int. My decal type of k is int. So the R value reference, of course, went away again when I gave it a name. That's the whole concept of R value references. But also the const of my j here went away. Now imagine that you have a function that was generic and it returned you a value, and you wanted to do something with that value, and then you wanted to give it onto another function. That other function was overloaded in a L value version and an R value version. So one taking a const whatever thingy reference and one taking a R value reference to that thingy. The question is, how do you hold that thing? If you hold it just like with an auto like this, so I came from somewhere. It could be either it could be the return of a function f, and it was either an r value or an l value. How would you possibly hold it? Because here you get that information thrown away. And the answer is you will hold it with this syntax here: auto reference reference l. So this is a perfect forwarding reference. I don't know if that's a name, but I now hold this and retain the type, as you can see down here, printing the Decal type of L and M. This is an int reference when I got it from a J. And when I moved it, so I got an R value here over into an M, then it's an int reference, that is an R value reference. And now I could call another function G that was overloaded in an int reference and in an R value int reference. Well, you know what I mean. Okay, I got a bit carried away, I admit. But the key thing is you can print the type of things using this temporized specialization without a specialization for that particular class. And that's super, super useful. So better make a note about that particular code, because you will want that a lot in your future. If you think that, hey, this last thing that he was talking about was rather interesting, let me point you to a Back to Basics talk from 2019, I believe, at CPPCon, where there was a presentation on move semantics. And at the end of that presentation, he talked a bit about this stuff. Sorry for not remembering the name of the presenter, but you will recognize him as soon as you start the video. Until next time, have a great time. Ah, all those colors again, seriously? Now again? Okay, so I am. Seriously? What I've been told to tell you is that I'm not the smartest guy in KDAP when it comes to C++. We have way smarter people, and they are equally good at explaining stuff as I am. Thank you very much. So maybe you should join one of our C++ trainings and learn about move semantics, perfect forwarding, template specialization, and a lot of other topics. See our scheduled training on the link above, or maybe get one of our trainers to come to your place.